Before we get into our elliptical table, I do have a little side mission that I'm going to be working with you on. It's a small favor we're doing for one of our clients, actually. So it's nothing super complicated. It's another table, but it's a lot less complicated than the elliptical table. So I figured we'll start here and then work our way into the elliptical table, probably in the next video here. So this is essentially what we're designing today. It is a sort of a smaller, I think it is a coffee table. It's only 30 inches tall, so yeah, more like a coffee table. We have an inspiration photo we're working from. This isn't very typical, but we got an inspiration photo we're working from. We have some dimensions to work off of down here, being that it's a 96-inch wide table by 40 inches deep and 30 inches tall from the floor. Um, so we do have a dimension here. We're trying to maintain a 6-inch overhang on the sides here where the legs come up. We've also been tasked with finding an angle that'll work with this table. Now, normally you're going to be getting this information off of an architectural drawing. In this case, this is just kind of a conceptual type of thing. And so like I'm kind of working with um, the person that needs this as a favor here. And we also got a couple other things to note, that all of the material is going to be an atypical thickness. Every piece of material on this is going to be constructed using 2¼ inch thick material. So that is not standard. I would kind of take note of that you're not going to usually use that as a material for tables. In this case, it's kind of a weird case, but that's what we'll be using here. And then anytime that you are using solid lumber, it's also important to remember that solid lumber will come in specific sizes. So if you are dealing with a table that has like 6-inch wide lumber, like what I have noted right here, there actually is a finished size and a nominal size, or an actual size and a nominal size for that lumber. So you always want to look that up before you get into drawing anything with solid, especially like planking, tongue and groove boards, slats, anything of that nature that deals with solid. Always, always, always look up online what that actual number would be. And let me see if I can pull up a chart that shows that. So nominal versus actual solid lumber chart. Show you what that is. If you go to like the hardware store, like a Menards or Home Depot, they're gonna actually have something like this too. Here, I'll pull this over to the side so we can see that. So as a piece of lumber is milled, it may be labeled as a 1x2, but the actual dimensions of that lumber will be 3/4 by 1.5 inches. So always important to remember to check these out before you get into drawing something with solid lumber. Also, if you're building a house or designing a house or anything like that, also really pertains to that too. But in this case, we're building a table out of solid lumber that's left over from another project that we have done here. And so we're dealing with these solid lumber sizes here. So let's go back to our drawing right there. Like I said, we know the dimensions of the tabletop. We know the height off the floor. We also know the setback of being 6 inches from the outside edge of the table to the start of the leg. But we do not know the dimension from here to here. So we're going to have to sort of puzzle that together and figure this out. So real easy though. We have CAD, so we can do this. Let's go back to our example photo. I'm going to split screen this again, kind of like we've been doing for a lot of our other projects. We're going to split screen this, and we're going to pull up AutoCAD, and we're going to start looking at this one together. So I kind of did a mock-up sketch of these the other day for our client, and we did use, I started with a square leg, making the leg completely flat, like vertically to the floor, square. And then I kicked the legs in 5 degrees, and then I kicked them in 10 degrees to show the client like what that leg would look like in those 3 different scenarios, so they could kind of look at that, maybe either pick one of those sizes, or angles, or even maybe kind of like go through and design it or pick a different angle if they wanted. So this one won't take very long. I actually don't have the materials for this, so when we go to plot this, we're not going to actually be labeling the materials the way we normally would. I'm going to label them as like SD-X and then write it as TBD. And it's mostly a design drawing to show like how this thing will actually kind of be coming together so they have something to work off of. So because this is a favor for a client, this isn't for an actual job right now. So what I'm going to do is go to engineering in-house. I'm going to pull up a blank template so that way I can start with one of those. Let's see, master template. We're going to go with our newest one here from February. And let me kind of drag this over here, kind of drag this over here. Whoop. Okay, there we go. Now let's kind of begin with this. So right now, there is no architect here. There's no general contractor because this is also sort of just being designed by Onsite. So I'm going to write NA for these. Job name, I'm just going to say Keaton's house. Drafter, I could put my initials there. EM, put Keaton's initials there. Job number, we don't have one, so I'm going to leave it with a bunch of X's for now. And contractor, again, there will not be a contractor on this because it's not really an official job. So NA for that. Because it's not an official job either, it won't be QCP lead or FSC, so those can remain unchecked. And we will probably go ahead and give this a label of F1 for furniture 1 or specialty furniture 1 for the page number. And then what I can do is save as and save this to, it might be a weird area to save it. I'll save it under our AustLT&M folder for now. I'll have to ask him where or what he would like for this to later on. So PKT 1, 2, 3, 4, 5 X's. There's not a packet number yet. Probably won't be unless he has it sent in the shop. So F1 packet number. We'll call this table level TBD and room TBD. All right. Oh, and then of course version 1.0, just like we always do for the first draft of the item. We're going to save that. And I'll update this too, since I just typed that out in there. So instead of subject, we're going to write table. Oh, and all caps, of course, table. Level TBD. Room TBD. And room number TBD. Okay. All right. We're going to save that one more time, and then we'll begin working. All right. So let's start with let's think, how do we want to start this? Let's start with a section view or a side view of our table, so we can kind of get an idea of what it is that we're dealing with here. So you can start anywhere you'd like. I'm going to kind of start over here in 3D model because at the end of the day, what I'm going to do here is make a 3D model to kind of go through the steps of flat shotting and making section views off of that model for you. So let's start with what we know. So section view, if we were going to draw a section view through this item, we know that the tabletop is 40 inches on the shorter side. So I'm drawing this facing the shorter side of the table or looking at this side over here. Okay, so let's start by drawing a rectangle. And this rectangle is going to be 40 inches wide or deep, and then it needs to be 2 1/4 thick, like we said right here. So 2.25 thick. Okay, so we've got now a rectangle at 40 inches by 2 1/4 thick. All right, so then from there, let's sketch out some parameters here or some construction lines to show like where our limitations are here. So we do know from the top of that table down to the floor has to be 30 inches tall. So let's draw a line 30 inches down from the top of the table. And then what I'm going to do as well is kind of draw in a baseline like this, just to show where the floor would be. So I can now delete that 30-inch line because right now this floor line is 30 inches from the top of that table. All right, so we have some other base dimensions we need to include. We've got this leg starting 6 inches in from the side, and we're going to do the same thing over here, 6 inches in, draw a line straight down, and then delete these little extra lines. So that leg has to start right there and right there. Depending, or it doesn't even matter what angle it is, it starts there. So then what we're going to do is we are going to take, let me think about this. So yesterday I showed him a couple of examples. The one that would be a really good angle that he wants to try to use is a 10-degree angle. So we're going to use the rotate command to rotate these lines 10 degrees from where they're currently set. So I'll show you how you can do that real quick. So I'll use rotate here. Okay, and then when you select your object, we'll start with one of the legs first, hit enter, and then select your base point. And here what I'm going to do is select this endpoint because this endpoint is set in stone. It's already 6 inches back from the front of my table, from the front edge of my table. So I know that can't change. So what I can do is click on this endpoint. And as you notice, as I just turn off my F8, my ortho snap, as you notice, I can spin this leg around, but I can also type in a rotation angle, as you can see in the gray box to the right of my cursor. And when you type in an angle in AutoCAD, you always got to remember that angle is going to be going in the clockwise direction. So because I know I want to spin this 10 degrees this way clockwise, all I got to do is type in 10 for that. For this leg over here, we'll do the same thing. We're going to use the rotate command again. Use that endpoint right there. Now, in this case, I can't just type in 10. If I type in 10, I'll show you what will happen. It's going to rotate it that direction. And based on the reference photo we have, that's not really what we're going for. So what we're going to do is we're going to use that rotate command one more time. And instead of 10, you can either type in 350 degrees, which would be 10 degrees less than a full 360 rotation, or you can type in -10, like that. If you type in -10, it's going to rotate it 10 degrees in the counterclockwise direction. Because you always got to remember when you're dealing with angles in AutoCAD, AutoCAD really, really likes going clockwise. So if you want to go counterclockwise, you either use a negative number or you have to do the math and figure out what that would be. So then what I'm going to do is use the extend tool. I'm going to extend these lines to the floor because right now they're floating above the floor. So we need to do that. Okay. And then just like before, even though this is a weird thickness of material that we're not used to using, we do need to offset these lines over 2 1/4 of an inch. So use the offset command, 2.25, bring that line in, 2 1/4, bring this line in, 2 1/4 like that. And then you're going to be extending and trimming these lines. So again, now that I've offset that line doesn't touch the floor, I need to extend it down. And then up here, I need to trim these lines back. So if you're already in the extend command, you can hold down the shift key and it will toggle on the trim. The opposite happens too. If you're in the trim command and you hold down shift, it will actually extend the line that you click on. So kind of a cool little nifty thing, save you a little bit of time later down the road. All right, so we do still need to offset this line at the floor. We're going to offset this up 2 1/4 to deal with that material thickness just like this. We are also Looking at the side of this, although it's not sketched in this little hand sketch here, there also is a 2¼ thick board that sits right below that countertop right there. It's not in the sketch, but we do need to include it as part of our drawing. So what I'm going to do is draw a line, and now I can either offset that line or I can use the move command, selecting that line, and make sure your orthosnap is turned on. So that way you're locked at your 90-degree increments, and you can go down 2.25, just like this. Okay, and then what's left is to trim. So we're going to trim all these lines back, and the inside portion is going to butt into the vertical or sort of angled leg. It's hard to see in that picture there, but that is what's happening, and also what's happening here too. If it wasn't like that, you would definitely see an extra line right here where those two materials meet. So we know that that vertical leg is stopping at the floor, and this horizontal piece is stopping at the side of the vertical leg. So we got to trim all of that back, just like this. Okay, so now we've got essentially the side view of what we're dealing with here. So not too crazy. Give us a little bit of experience with using rotate and negative rotate. We've got our table dimensioned correctly at 40 inches wide, 2¼ thick. Legs are drawn in at the correct angles, and all materials being 2¼ thick. So now what we want to do is we're going to take this table and we're going to actually make it into a model. So for us to be able to do that, let's clean up any extra lines that we don't need. Kind of like this. We're going to trim those back. Everything else looks like it's pretty ship-shape. I think we're good there. So what we're going to do now is we're going to use this command called bpoly. Bpoly is going to allow you to create polylines based on already existing lines in your AutoCAD file. So you start the bpoly command, and when you start that, this menu will pop up. And the first thing you're going to want to do is click on this icon that says pick points. What that does is it lets you select an internal point in an object, and then AutoCAD will scan the lines around where you clicked, and it will create a polyline around that object. So we're going to use that here, and we're going to click on each part that we want to make into a 3D part, just like that. When you're done, hit enter, and then you should be left with 5 polylines here. And you can see that by clicking on them, that you are able to select those as solid rectangles instead of individual lines. The one downside to using bpoly, though, is that every time you use it, you're going to be left with the lines that are underneath still. So it's kind of hard for me to see, but there are some loose lines that are sitting down there. So what we're going to do to remove those, I'll show you a really nifty trick you can do. Highlight everything that's here in your side view. Go over to your properties pane, and you're going to want to go up to this icon here. This is called Quick Select. It's in the top right corner of your properties pane. It's got a little yellow lightning bolt on it. If you click on that, you can see that there are settings here that you can mess with. So right now it says apply to current selection, which is exactly what we want. So we've already got some items selected, and we're going to want to tell it that we want to select lines only. So we're telling it do not select polylines. We want to only select the lines. And then at the bottom, it's going to ask you for a property to use to be able to select those lines. And so what I'll do is I'll just say select all, because I don't care what color that is or what line type it is. I just want all those lines gone. So I'm telling it I want to select all lines, not polylines, and I want to select all. Then what you want to make sure is you have this include in new selection set toggled on, and hit OK. Once you have that, you can hit delete, and you should only be left with polylines now. So to check, you highlight everything there, go into properties, and at the top, it's going to say polylines quantity 6. If there's anything else in there, I'll show you what'll happen. So I just drew a line in. I highlight all that again. You'll see it says all quantity 7. And if you click on that, it'll say there's 1 line and 6 polylines. You want to get it down to only seeing polylines though. So you want to get rid of any excess geometry that doesn't need to be there for this. Once you've used bpoly and you've cleaned up your side view, now we'll get into the 3D modeling aspect of this. So one thing that I always like to do before I even get into modeling is if I know that I'm working in this grid that's right here, it's really, really convenient for 2D modeling, or sorry, 2D drawing. But if you're 3D modeling, this does slow down your AutoCAD. So one thing that you can do to sort of accommodate that is you can highlight your side view, and you can tell AutoCAD you want to use the isolate command. Once you've done that, it will hide all of the rest of that grid, and therefore AutoCAD doesn't even know that it's there right now. It actually is there. I can type unhide or unisolate and it will bring it right back. But right now I'm trying to avoid seeing it because it will slow down my computer. I don't really want that. So before we get into 3D modeling, we always want to make sure we're looking at the object in a 3-dimensional view. So what I'm going to do is start by clicking on the corner of my view cube. You can pick whatever corner you'd like, but I kind of like to start with the bottom left corner. And then what I'm going to do is use the press pull command here to start to draw this leg and tabletop. So tabletop we know is 40 inches wide, and we also know that it's 96 inches, well, 40 inches deep by 96 inches wide. So we need to use press pull and extend the tabletop 96 inches this way. I'm still in 2D wireframe, which is perfectly fine. If you like modeling in wireframe, you can use that, no problem. If you like seeing the objects in 3D, you can use, I'd recommend either using conceptual or shaded with edges. I'll just go to conceptual here. Okay, and then the legs. So again, the legs we know are, they're 2 1/4 thick, which we've already got drawn thickness wise, but they're going to be 5.5 inches wide on the other side. So as I use the press pull command, I can click on the parts of my leg and extend them 5.5 inches up. If you want to do multiple objects with one press pull command, you may. You just got to hold down Shift while you're clicking on the profiles that you're trying to use. Once you've done that, you can hit Enter, and you can press pull all sides of that leg instead of just one at a time. All right, so we've got the leg modeled. We've got the tabletop modeled. One thing that I want to make sure that we do as well is make sure that this leg is set in 6 inches from the side of the table over here too. So we're going to use the move command, highlight the parts for the leg, and we're going to move that 6 inches in the Z direction. Okay. And then one more thing. Before we flip the table back over to being a normal sort of view, I'm going to use the 3D mirror command to get the other leg to show up. So use 3D mirror. I'm going to highlight the parts of my leg like that. And then I'm going to hit Enter. And it's going to ask me for 3 points. These 3 points are critical to make sure you get them right. So the first 2 points are super easy. Those 2 points are going to be the middle of your table. So middle of your table here, middle of your table here. The third point has to be on the same plane that you're flipping this across. So imagine you're drawing like these yellow dashed lines here. Imagine you're drawing a flat surface in the middle of your table, or a flat plane in the middle of your table. Just like when you use the slice command or the section view or the section plane command, what you're doing is you're drawing a fake plane. Like it's not there, but you're drawing it in and telling AutoCAD this is what I'm using to flip over on the other side. So this has to be in the dead center of where you want to flip that. So these 3 points here although this one's kind of floating in space, it is still going to be a point that will work to flip this leg across the other side of that line. So it can be anywhere over here, but it wants to be in that Y axis or Y direction. So we need to go straight across like this. Once I click my mouse, you'll see that it's going to ask me, do I want to delete the source object? And I'm going to say no. If I do check yes, what will happen is this leg will disappear and then a new leg will show up here. But I don't want to delete this one. I want both of these to be here. So I'm going to say no. All right. So you can see I've got this leg. And if you want to verify, you can do a DI or DIST and check to make sure this leg is in fact 6 inches from this side and 6 inches from this side. You can see right there that that is. And we'll check this one as well. 6 inches and 6 inches. So now that I'm confident that my table is drawn correctly and the legs are drawn at the right location, what I would like to do now is use the 3D rotate command to flip the table so it's facing the correct orientation here. So 3D rotate. We want to make sure we highlight all of our 3D parts. So make sure you grab all of those. You don't need to grab any of the polylines or the 2D parts, only the 3D parts. So I'm going to hit enter. And then you can see this gizmo will pop up. And you're going to want to select the correct axis that you're going to flip the table on. So this is a little tricky to get used to at first. It's always going to be, if you want to visualize just that one circle that you're looking at. So like if I use the blue circle, you're going to see what would happen is I'm going to rotate my table like it's breakdancing in a circle like this. Like it's going to go in that direction. And you really don't want that. So again, let's 3D rotate that one more time. And fun fact too, if you already had something selected and you want to reselect those parts again, once you start a command, type in PR and hit enter. It will automatically reselect the last object selected. So if you want to do that, if you mess up something by mistake, you can use that to quickly get back to where you were. Green axis, again, isn't going to be correct because you'll see what will happen is the table is going to rotate this way on that green circle. So really what we want is the red circle here. Red circle is going to be so we can flip it this direction here. Now, to get it to be straight up and down, you type in or click on your F8 key to turn on your ortho snap. You want to rotate it 90 degrees so it's facing straight up and down like you would like to see it. So just like that. Now I can delete the 2D lines that are at the bottom. They're not important anymore. And then one last thing to add is we do need to add in, it's hard to see, but if I can zoom in a little bit, you will be able to kind of see what's happening here. There is a beam that runs across the floor and a beam that runs across the top. And these are both dead center of the table. So we need to add those in. And then once we've done that, this model is essentially done. Again, kind of circling back to the 3D commands, if you hold down Shift and middle button on your mouse, you can orbit around your model if you need to see a specific angle or something like kind of hidden inside of there. Middle mouse wheel scrolling towards your monitors will be your zoom in. Scrolling away from your monitors will be your zoom out. So just a little bit of recap on that. All right, so because we need to add those beams in, let's go ahead and use the box tool to do that, because in this case, we don't really have any 2D lines to press pull off of, so we're going to use the box here. All right, so off to the side, what I'm going to do is just draw this box, and I'm going to make it the correct dimension. So right now we talked about these boards are 5.5 wide by 2 1/4 thick. So let's do that. So 5.5 wide, hit your tab key. And this is going to be to specify the length of that board. Now, right now, it doesn't really matter to me what the length is because I'm going to use either the slice command or the stretch grips on the box to shrink it to the correct size. So I'm just going to make it a random length at 200 inches long. And I'm going to hit enter, which will allow me to now enter the vertical height of this board, and that would be the 2 1/4 thick part right here. So 2.25. All right, so now that I got this board off to the side, I'm going to use the move command, and I'm going to place it exactly where it needs to go. So what I'm doing here is I'm using the move command, grabbing the midpoint of the bottom of that board, and then I'm going to use my shift and middle mouse button and rotate my view so that I can see the underside of my table. And I'm going to use this midpoint on this board to then drop that board where it needs to go. All right, and a couple of things you can do to resize this, because right now, of course, it's too long. A couple things you can do is you can use this triangular grip point. It's really hard to see on my screen here, but you click on that and it allows you to stretch that box down to there. You can do it that way. If I go back a step, another thing you can do is you can use the slice command, highlight your board, and then it's going to ask you to select 2 points. So usually what I'll do is click on this point, because that's where I need to chop it at. And then it's going to ask me what side do you want to keep. If you'd like, at least when you're new, it might be beneficial to keep both sides. If you are more comfortable with AutoCAD and you're okay with picking a side without, goofing anything up, then you can just click on the side that you want to keep. So here, what I'm going to do is click on this point here, and it will only keep this side, and it will erase anything past those 2 points that I selected. So now what I'm going to do is copy this board using the copy command and the midpoint up here. And then I'm going to drop that right at the midpoint right there. Okay, so that gives me those 2 beams that help connect these 2 legs together and help brace this table. Hard to see, but they are there. Okay, so now that we've got that, we are now able to go back to our grid. So we're going to unhide or unisolate. We're going to bring back our grid. And then what I would like to do is line my model up with where the grid meets. Just like we do with 2D drawings, that's what I'm going to do here. So I'm using the move command. I'm going to highlight all my 3D parts. And I'm going to start by putting this corner where the grid meets, because that's the furthest out corner of my table. But you can see as you pan around or orbit around that my table is now sitting below the grid, which, I mean, personally, I'd rather have it above it or right in line with it. So to do that, because we know our table is 30 inches tall, according to our specs over here, we're going to use the move command, and we're going to move this up 30 inches like this. And now if I orbit around, you can see that I'm sitting right in line with that grid, just like that. Hard to see, but it is. So now that we've got that, we got our coffee table all modeled. It's looking really good. What we can do now is I usually will flip back to 2D wireframe for my visual style. So we're going to go back to 2D wireframe, and then we're going to start doing our flat shots. So I like to start these in the order of which I'm plotting the drawing. So just like when you plot a drawing, you always start with, if you have a model, you're going to make an axonometric view. You're going to go to your plan view if you have one, RCP if you have one, which we won't have one here. Elevation views will go here, section views, and then of course detail views. So because we have a model, we are now able to make an axonometric view off of this drawing or this model. And what we'll do is I'll highlight the model here, and I'm going to click on a corner of my view cube, kind of like that. Okay, so to make a axonometric view off of the model, you're just going to type in flat shot. The menu for flat shot will pop up, and you're going to then make sure that all these are set to by layer. And you're going to turn off the obscured lines here. So we do not want to see those. We're going to turn those off. And then we're going to hit create. So you can see we got a nice view of that table we can just set it right there. Flat shots are a little weird. When you do place them on your drawing, it's going to ask you for an X scale factor, a Y scale factor, and then a rotation angle. So because we draw everything at full scale anyway, we don't want to scale it by any means. So we're just going to say scale of 1 for X, scale of 1 for Y, and then the rotation angle is going to be 0 degrees because we don't want to spin this at all. All right, once you hit those, we're going to go to move, and we're going to now place our table axonometric view on our grid. I just kind of grab the corners of this to place it like this. All right, so we still need our plan view. So again, what we're going to do is flat shot again. And this time, because I've already set all of these, I don't need to change any of them this time. I can hit create. And you can see it's placing it right there. I want my X scale factor to be 1, my Y scale factor to be 1, and my rotation angle to be 0. All right, let's go around and make our elevation views next. So using your view cube, you can spin it facing this way. We'll do a flat shot of our side view. And it's kind of hard to see it because it's placing it on the XY plane. And right now we're looking at the XZ plane. We're looking at the side of that 3D model. So really you can't really see that. But what we're going to do is use the shift and middle mouse button to spin our view around so you can actually see what we're doing. We're going to place that view here. X scale factor 1, Y scale factor 1, rotation angle 0. So we'll move that over here. All right. And then we need a elevation view of the other side of that table still. So what we need to do is use the view cube again. What I like to do is click on the side of the view cube that I'm trying to hit, like what I'm trying to look at. So left side here. We'll make sure we're looking flat at that side of the view cube. And we're going to take that flat shot now. So flat shot there. Settings are already set. So we just hit create. And then we can drop that view right alongside our elevations. X scale factor 1, Y scale factor 1, rotation angle 0. At some point, you will get super quick at that, and you won't even have to think about it. It'll just be like boom, boom, boom. So just like any other drawing, what I like to do is also make sure that my views are lined up, but also give them an adequate amount of space between views. So that way, as you look at these, you're not having dimensions that show up in other viewports or off to the side or overlap or anything. So you don't want that. We kind of want to give us enough margin space so that that doesn't happen in the paper space later on. All right. All right. So what is left? So we've got our axonometric view, our plan view, got our 2 elevation views. We don't really need all 4 because there are 2 duplicates there. And then we need our section view. So section view is really easy here. It's really a simple one. We could draw it out by hand. Really, what I really would like to do is show you again how to use the section plane tool in your 3D modeling toolbar. Again, if you are not seeing these up here, these commands, and you want to get to those, go down to your settings gear down at the bottom. And typically you're going to be on drafting and annotation for any 2D drawing or modeling, plotting. If you are working in 3D, I highly, highly recommend opening up the 3D modeling toolbar. Once you've done that, you should see all of these commands that are up here. And we're going to open up the section plane command here. You can also type it in too, but it helps to be able to see that stuff in case you ever need it for anything. So section planes work a lot like the slice command or that 3D mirror command we just looked at. It's going to ask you for a couple of points to draw a section plane. And how you want to visualize that is I'm clicking here and I'm clicking here because I'm chopping my model in half at those 2 points. So that line there is where it's being cut in half. So you can see exactly what it did. The gray boxes are where things are being chopped. the blue lines that you're still seeing there are things that are in the background. So now to make an actual section view off of this, you need to highlight that plane. And then this menu will change, and you're going to go down to Generate Section Block. And you're going to hit Generate Section Block below that drop down right there. All right, so again, kind of recapping what we've talked about. If you are in here for the very first time, it's going to look like this. There's not a lot going on. Just make sure that your 2D section / elevation object is selected. And then you're going to go down to this caret here to say show details. And this is going to get really complicated. And what I would like to do is just make sure that if you need some time to go through these, you can pause the video as I get through this to kind of copy these section detail settings. But we're going to click on this section settings ... box at the bottom. It's going to open up this menu here, and you're faced with 5 different groups of settings. So the first one, breaking it down one by one, intersection boundary. Intersection boundary is any lines that are going to be created where the section plane is cutting through your model. So what you're going to do is you're going to make sure that these are all set to by layer, and that the layer is set to geometry, which is your standard line layer. Line type is going to also be by layer. And I think that's all you really need there. So we're going to leave the rest alone. Go down to the next one here, intersection fill. That's just a fancy term for hatching. So when you see intersection fill, just think that's my hatching there. So we do want to see the hatching. We're going to set this to be, well, it's already set this way, but predefined / solid, which means that it'll just make a solid hatch until you change it. The color, we're going to set that to by layer. The layer, we're going to set to hatch, of course, because that's our hatch layer. And then line type will be by layer, and that's all you need to change there. So I can close these out because those are going to be done. At the end, I'll open these all up again so you can pause the video and set your settings as you need to. Moving on to background lines. Background lines are going to be anything beyond the section plane. So anything that's past that section plane is a background line. So we do want to see those, but we don't want to see the hidden lines that are anything beyond those. So hidden lines, if you had something that was behind your background line, it's kind of weird to think about that in so many layers, but you don't want to see those hidden lines, you want to turn them off. So we'll say no to hidden lines. Color is by layer. Layer is geometry. Line type is by layer. And then the rest of these, just to make things easier, these 2 at the bottom that are in red already just don't need to be on at all. So you're going to say no, and you're going to say no to both of those. So I'll open up all of our settings again. You can go ahead and pause the video here and make sure that these all match to what you've got on your section settings toolbar. Once you've verified that, you're more than welcome to hit OK. And then you're going to hit Create. You'll see it populate a section view based on the settings we selected. We're going to drop that over in our section view over here. So we're going to drop that and make sure our scale factor for X is set to 1, scale factor for Y is set to 1, and rotation angle is set to 0. So then we're going to move that view just like any other view. So none of that changes depending on 2D or 3D drawing. It's all the same. You line it up with your grid, and then you're done. I like to also delete that section plane once I'm done with it. So I can highlight that and delete it. I've had problems in the past, just to give you forewarning, that sometimes if you keep that on and you don't delete it, there have been times that I have seen, and this might just be a fluke, but there have been times in the past where I've been working on something and part of my model, when I go back into that CAD file later, is gone. Don't know why. I cannot explain how that worked, but it's almost like it sliced it and deleted it. So you got to be really careful about that. I usually just delete it to be on the safe side. Could be old, could be fixed by now. Autodesk probably already addressed the problem, but I don't want you to fall into that same bucket that I did. So let's just pretend that that problem still exists, and we're going to delete that section plane to make sure that we don't have that issue. So now that we've got our views, this is basically the same as what we've done before for 2D drawing, except for the one last thing we got to do. So anytime you take a flat shot or a section off a 3D model, it brings it in as a block. You can see that if you click on those and you go to your properties, it does say they're block references. You can use them as a block reference, but I prefer that you go ahead and highlight these and then use the explode command to explode those blocks into regular lines and geometry. You'll see that sometimes the flat shots will go back to being the standard layer 0 color. And if that's the case, I want you to kind of go back into your properties and just change that to make sure it's by layer. Make sure that you're on geometry still. And then make sure that your line weight is set to by layer. If it's set to 0.00 millimeters, of course, when you go to print this drawing out on paper, that view is going to turn out so light that you won't really be able to see it. So you want to make sure that those are set to by layer for all those settings, and the layer is set to geometry. One last thing to worry about here in your section view are these solid boxes. These are going to be the intersection fill or the hatching. So what you want to do is you want to change these out. If you click on these hatch boxes, what you can do is go up to your hatch toolbar at the top. And if you have things like, if you know what that hatching needs to be, for instance, in this case, I know this table is actually being made out of solid lumber. So I'm going to set that to be Legno 1, which is essentially on-site standard for solid lumber. Over here, there's a setting for layer or hatch scale. And if you adjust this, you can change the amount of how much hatching is shown. When it was set to 1, by default, it looked very crammed. And so what I'm going to do is set this to be like maybe 3 or 4. That way it's not so crammed and congested. And then I'm going to use my match properties command here, which is probably new to you. Match properties will allow you to highlight an object and then kind of color by number, paste that into other areas of your drawing. So I've got all my solid lumber hatched, and I've got all my views placed, and they're all on by layer, geometry, and the line weight is set to by layer. So now that I've got that, what I can do is I can start to put this on paper. So let's see, how are we doing on time? I'm sure we're way over on this video because it's taken a minute. Where's my timer at? Oh, and we'll be all right. We'll be all right. All right, so let's go ahead and take a look at this. So let's go ahead and plot this to the best of our ability. Like I said before, I don't have a solid finish call for this because it's not a real job and it's just a favor. So what I'm going to do is play around with my views just like you would for any other drawing. I want to make sure that this is set to something that looks adequate to the paper size and the views that we have on the paper. I might make all of my views 1.5 inches equals a foot just to be consistent. I know that's not typical, but this is a very small table, and so everything will fit on this page at that scale because of the size of the furniture that we're dealing with. So I'm going to use the move command and move my viewport using the corner where the two grid lines meet, snap it to the corner of my view title, and then raise it up 1.5 inches from there. Once I've done that, I can go ahead and move these lines around like this. And I should be able to place this view. Oh, hold on. I forgot I did something earlier today. I need to lock my, I need to lock these lines again. I unlocked them for something earlier today, and I didn't mean to do that. Okay, so now let's move this up to somewhere closer to up top, to the top of our view. Because if you remember, when you're plotting a drawing, you want to go top to bottom and left to right, just like you were reading a book. And your views do need to be in a very specific order, aside from detail views. We're always going to go axonometric, plan, RCP, if it applies, and then elevation, section, and then again, just to recap, details are anywhere they can fit. So to make this work better, I might flip this view. Hold on a sec. I'm going to go over to my model space and rotate my tabletop so it's facing a different direction here. I want to make sure that it'll fit on the page. I think right now it's going to be just a hair too tall to fit. So let's try to make it fit this way and see what happens. Okay, that looks much better. So again, using the move command pretty religiously, moving that to the corner of my view title, and then moving my view up 1.5 inches. That way I have the same exact margin space all the way around my drawing. Once we get to the end, we're going to go back and we're going to also make sure that all of our view titles are showing the correct information here too, at least to the best of our ability. There's going to be things that aren't going to make sense because we don't have arc references for the majority of the work that we're dealing with here today. So most of that's going to say NA, but we can still work around that. So again, move my view, set my scale, move my view up 1.5 inches, boom, boom. And then I like to bring these in to match up with the grid on the drawing. So something like this is fine. Keep on moving. All right. Let's see about this. Let's see what we can do here. I might regret my words about making everything 1.5 inches equals a foot scale because it looks like we're getting a little cramped now, but we'll see if it fits. Oh man, it might just barely work. Recap as well. Make sure that when you are copying your viewports using the AutoCAD version of the command COPY and not Control-C and Control-V, or you'll break the formulas that we have populated in there. So it's easy to do. I've done it so many times. I've seen other people do it too. But make sure that you're using COPY, not Control-C and Control-V for this. Okay, now that I've got everything on the paper, and it actually all fits, miraculously, called it, we need to set up our viewports, our view titles now. So this will be view 1, and it's going to read axonometric view rather than plan view. So axonometric view at table, you want to take this and you want to make sure that it's lined up with your text like this as best as you can. And we don't have an arc reference here, so we're going to write NA. You'll also notice that the view scale is reading NTS, which means not to scale. That is just a signifier that says, hey, please do not try to scale this view. It is more for display purposes only. It's a preview of what the drawing is. It's not actually to build off of. Even though it is a 3D model and the model is accurate to what we're building, we don't want somebody to use a ruler or a architectural scale on it to try to pull dimensions off of it because it's just not going to work. All right, so view 2. View 2 is our plan view, so that's already set correctly. We do have to adjust our length of our text here to match up with the text above, and our arc reference will be NA for not available. Side view, this will be an elevation here. Elevation view at table, stretch this over, and then adjust it to line up with your text there, and write NA. And make sure that you don't forget your number 2. I almost did. So view 3, moving through, this will be view 4. Switch this to say elevation view. Adjust the length of your 2 lines in there. I'm going to try to do that again because I want to make sure that's as close to the text as I possibly can be. And then arc reference will be NA. All right, and then view 5. View 5 is going to read section view at table. Adjust this guy again. Arc reference is going to say NA. All right, so last thing before we start dimensioning and tagging, let's make sure that all of our viewports are locked and at a actual legitimate scale and not some weird decimal. You'll see your scale factor right here next to the lock. Make sure that is set to what you want it to be and not something goofy. If it's set to something goofy, odds are you may have had it unlocked and you might have zoomed in a little bit and it will affect the scale here. So be careful not to do that. All right, so I may just slide these down a grid space and adjust the height of these to the up 1 grid space. Not that it matters too much, but I'm doing that to give myself a tiny bit more space with my views because it'll give me more options to place dimensions and tags around my drawing. So that was super simple. It all fits on one page, not a real complicated drawing here. Let's go back to the drawing though, because I need to add in my floor hatch for my elevations and my section views. And then once the floor hatch is applied, then I'm just going to dimension and tag everything. Super simple. That's why I wanted to start with this one first. It just came up as a what I call a side quest yesterday. I figured this would be a perfect opportunity to try to do some 3D modeling with you. So it's a simpler table. It does have angles to it, but it's a simpler table in general. And so with that being said, it was a great opportunity to jump in and start to do some modeling. So, all right, let's start dimensioning everything. So tabletop, let's go here. We'll go 40 inches for that dimension. And what I like to do, again, just to not to really beat a dead horse, but like definitely like to make sure that all my dimensions are pulled off my view at the exact same offset. So I'm going 4 inches here off my view, drawing a line 4 inches down off my view, snapping my dimension to that 4 inches, and then deleting it. All right, there's nothing else to dimension in the plan view. Really all you can see is the tabletop, so nothing really to worry about. Let's go down to our side view here. So side view, what I'm going to do is also include the tabletop depth. Same thing, 4 inches offset from the view. I'm going to treat this like you would treat a cabinet drawing. So what I need to do is go and provide some overall dimensions. So usually what I'm going to do is go floor to top of table or top of counter, if you want to think about it that way. That is pretty typical because when you get to your section view at the end, that's when you're going to be able to really get into the crazy dimensions for this. So I guess a couple of things I could throw in here if I really wanted to would be, let's see, do I want to put that there or put it in the section view? Let me come back to that. We'll come back to that one. So let's keep on going with what we've got. So tabletop width, we'll make that 4 inches up. Oops, I don't need to type anything there. And same deal, floor to tabletop will be 30 inches. So 4 inches out there to set my offset, drop my dimension right there, and then write in an AFF for above finished floor. All right, section view. Section view is going to be a little more dense when it comes to dimensioning. A lot more going on. We want to make sure that we provide the angles. We need to provide the provide more information here. So what I'm going to do is throw in this setback, that 6-inch guy that we drew into our model earlier. That's going to be right there. Dim linear. Let me go here, make that 6 inches over to there as well. And then I suppose what we could do is drop in that dimension there and probably drop in the same dimension down here for that. That way it's actually dimensioned somewhere on the print. I don't want to neglect that. I think it's really critical that that's there. It'll help whoever's building this actually be able to build this accurately to what they want. And then height-wise, dimensionally, of course, you could still go floor to top of table. Now, everything that is on this page shows that dimension already. So something I want to do is actually show from floor to underside of counter. And then I want to dimension the thickness of that counter from the front. So dim linear, we'll go and plop one of those right there. You'll bring that in a little bit closer to your view if you think it's going to look better. Personally, I like to have it as close to the view as I can without overlapping the view. So something like that would be okay. Even this here really kind of grinds my gears a little bit. I really don't like that, but it's kind of what it is. I don't really have room to put that anywhere else. So one thing else I'm going to do is also provide a dimension here to here to show what the setback is from the bottom of the table leg to the outside of the tabletop. So there to there, and that should be equal on both sides. All right. You can even write an EQ, I suppose, like that to signify these are equal and they're intentionally equal. Okay, so I got all my labels put in. Let's throw in some dimensional or angular dimensions. So dim, angular. Okay, so you can plop those in here. Try to get them to look nice, best you can. Kind of like that, and kind of like this. Trying to avoid a lot of overlap. Sometimes you can't. And sometimes with angular dimensions, it does still show the inch tick marks at the end. So what we're going to do is we're going to take those off. If you highlight your angular dimensions and you go into properties, there is a dim suffix right here that you can delete that and hit enter, and it will only show you the degree symbol and not the degree, then inches. Weird setting in AutoCAD, but it's there to kind of help with some stuff dimensionally for other dimension types. So it's there for that reason. It's hard to explain that without really going into a lot of detail, but that's why that's there. So dimensionally, I think we're good on this table. I guess one thing I didn't show, what is going on up there? Gonna go drive me crazy. Sorry, AutoCAD's glitching out a tiny bit up there. One thing that is not shown on here, but I do want to make sure that it is noted, is the offset from here to there. That 6-inch dimension that we already showed in the section view, but this is facing the other side of the table. So let's drop that in. So 6 inches there. And then because I'm showing that, I might as well dim continue and show a few other dimensions on this table too. To show some width dimensions here. I suppose I could do that here as well. I don't think I'm going to, since this is a lot more detailed than the section over here. I don't think it's necessary, but like here, we didn't have these dimensions shown anywhere else on the print, so I want to make sure that that's noted so nobody's left questioning, hey, how far in do the legs need to go from the side of the table? So, all right. Okay. Sorry, cold coffee. All right, so we just gotta put some elevation, section calls, and material calls on this now. So material calls, we'll start there, and then we'll go back to our section and detail calls. So material calls, there's one material for this entire table. It's going to be a solid of some sort that's left over from another job. I don't know what that solid is right now, so I'm just going to write SDX. Probably adjust this to be a little wider. And then I'm going to line this up with the corner of my table and then bring it up a couple inches and over a couple inches like that. Whenever you're dealing with solid, veneer, and sometimes laminate, you'll have grain directions too. So always take note of that. Anytime there is a grain direction on a material, you want to make sure that it is shown on the print. If we forget that grain direction, then it leaves it up to the architect to determine what that grain direction is. And sometimes they may pick something that's a little silly. So you want to be sure to make sure you're noting that on your print anytime you're dealing with a grain direction like this, or a material that has grain direction, sorry. So I'm just kind of copying these materials and grain directions throughout for right now. At the end of the print, we will go through and add in the last minute tidbits of like things like, sorry, the elevation and section calls from there. I think I'm going to actually center these using that move and mid between 2 points here. So I kind of would like to see that a little bit more in the middle. And then I'm going to do the same thing here too, just like that. I could also do that here too, maybe to make things all lined up and nice and pretty. I mean, it could look like overkill too, but let's go ahead and add a couple of solid calls on the legs here going up this way too. So 2 ways you could do that. One, you could put a leader on this guy and point to it and say this is solid X. That would be fine. And then you could do is you can use the align. So I'm going to use the align command. And I'm going to line this up using the midpoint here of my call and making it line up with that. And then use the midpoint of the other side and line it up. Of course, it's not going to let me click it, but right there. So that it matches the angle of the leg. And you can throw that there. What I'm also going to do is mirror this so I don't have to do that again. And I'm going to mirror this using the midpoint over here like that. Okay, so we've got all the solid calls placed on that view. Let's go ahead and move over to this view and do the same thing here. So because I've already got these kind of stacked up where they want to go, let's copy these using the midpoint of the bottom runner, paste that right there. And then I need to make a vertical one that's going to sit on the front of this leg. So just like this. Boom. Okay. All right. Now we're getting somewhere. Little fun thing you can do too, because this is open in the middle and over here as well. We can make an open to beyond call or call out. So how to do that is I'm going to copy a material call, go down to the drop down on that material call, go down to text with 2 arrows, and then we're going to write in here open to beyond. And what that allows people to see in the drawing, even though you can see it in the axial view above, it allows people to be able to see that this in fact is open and there is no like leg or panel that sits in here. So let's start by centering it there. And then I'm going to center it vertically between there and there, like this. Okay, and then we can move that over to here as well, since this is also open to beyond. If you really wanted to, you could also copy and paste that into your section view here maybe a little overkill, but you could put it there too. All right, so dimensionally and material calls, I think we're set. Let's add in our elevation section calls, and then we will call this one done. Kind of. Also forgot I gotta do my page notes, but there's not much to add, so let's throw these in. All right, so the front view is view 4. So view 4. Let's copy one of these up to the top. And we're going to rotate that around. And we're going to do the same thing here. So view 4. All right, moving on. Let's do the two sides. Sides are view 3. So back up to your elevator or your plan view. Mark those as 3 on F1.0. And we're going to place those on the drawing. Again, I'm offsetting these all the same distance, so 2 inches off of the view. 3, 3, 4, 4. Okay, moving on. So we have a section cut through the middle of the table. That is section view 5 on the same page. So let's go into our tool palette, pull out a section call, and place it here. We have to make sure that we're putting in the right spot. So because we are cutting through the table, through the middle, like we did during our modeling earlier, we're going to place that section call right there. And we're going to make sure that the tail and the head of that section call do not intersect the drawing at all. So make sure that they're hovering off the side of the dimensions and the view. And then also be sure you have the correct view number and the correct page number for that. Lucky for us, everything's on one page, so it does make things easier in that sense. So then I think we should be all set there. And then what we want to do is move on to page notes. Okay, so page notes. Really, this isn't a cabinet drawing. There's nothing to add there. It's not a banquette. There's no die wall framing. There's no base trim. I mean, really, you could put the floor and in-wall blocking by others. You could put that in there. That really would apply for the floor, kind of. Let's see, all bays to be finished in lengths. We don't need any of that. There's no weld notes, no equipment, and no poles. So really, that's all you need. Next up, we need to add a solid call, and this is going to be solid SDX, and it's just going to say TBD on that. I'm putting a sample number on it too, because all solid and veneer calls will receive a sample number through the shop, and that number will get applied later to the print. All that is a tracking number. Like we have packets, they have a tracking number for a sample. So as it goes through the finishing department, they can go back to it later if they need to and pull out a spec for an old sample. All right. No other hardwares, no other pulls, no hinges, nothing there of that sort. So like we're actually really good with what we've got. So really what we can do is we can save this and we can plot it. Publish. And we'll remove the model sheet. We'll keep the drawing sheet, and we're going to hit publish here. And because this is a weird one, I'm going to put it in Austal T&M, which just means that Austal Time and Materials, which is kind of a catch-all for things that don't have a job number. I'm just going to place it in here right now, and then I'm going to send it over to Keaton to review. But really, that's it. So super simple drawing, nothing real crazy there. It's a real tiny coffee table, which gave you the opportunity to do some modeling and also get to play around with flat shots and section views. So really kind of a nice little segue into where we're going next. So I'm going to stop this here though, and that's all we're going to do for this video.